Hello friends, this is your teacher Manish, and in continuation with our discussion on estimation, today I am going to start with CoCoMo model for estimation. So in our last video actually we saw what does estimation mean by, what is the importance of accurate estimations, and what is the reason typically estimation goes wrong. So these all things we have seen in last video. If you have not seen that, or if you don't know what it is, I suggest please visit my last video and see the details, get yourself introduced to the importance of estimation. So as mentioned in my last video, I would be touch basing upon certain models which are used in industry, okay, and as a part of that, today I am going to talk about CoCoMo model, which is constructive cost model. Now let me tell you, CoCoMo model is no more used in industry, but as per the syllabus prescribed, it is essential for us to understand this model because there are numericals asked in the question paper. Okay, and it's always good to know how estimations used to happen in those days in legacy technology, especially mainframe, COBOL kind of environment, and that's the reason why we will learn this model. But just you have to understand this, that it's no more a practice in industry to use this model, and I will be also telling you what is the reason. Okay, so let us go back. It was actually formulated by Barry Boehm in 1981, and this is a model which has got one variable and two constants. So it's a non-linear model, and the formula is effort equals to A star, A multiplied by size raised to B, where A and B are constant. We will see what those constants, or what are those values of constants, and how do they change based on different types of projects. But A and B, just remember, A and B are constants, and what is the variable is size. So what is size? Size is actually kilo delivered source instructions. So it is nothing but lines of code in thousands. So for example, if lines of code are 6500, then the formula will be A star 6.5 raised to B, because size is in KDSI, which is kilo delivered source instructions. Okay, so 6500 divided by 1000, because it's kilo, so 6.5, okay, would be the number that would get used over here. Okay, often in numerical I have seen students making a mistake. So whenever in numerical, if the size is given as 8500, so typically I have seen them doing A star 8500 raised to B. That's incorrect. Here when it's 8500 given, you have to take it 8.5. So A star 8.5 raised to B is what you get efforts. Okay, so remember, CoCoMo is an estimating model which is based on measurements made from few hundred projects. So whatever experience people got as a part of executing those few hundred projects in a company named TRW in 70s, okay, the CoCoMo model was built. So what should be the value of A for a specific type of project, what should be the value of B for a specific type of project, is all laid down based on the experience that people got by executing those projects. So there are probably 100 plus projects which were measured. The data of those projects was collected. Now the problem is, this was way back in 70s. So the projects which we execute now, the software development which we do now, is way different than what technology it was used in those days. So hence basically it's not applicable. And second problem with CoCoMo is this size. Finally, CoCoMo doesn't tell you how to arrive at size. CoCoMo expects you to know the size. Okay, and that's the second problem. But having said that, it's not used at present in industry, but from our perspective we are going to learn this, because numericals do come in exam, and we should also be aware how projects, how efforts were estimated in olden days on legacy technology. So constructive cost model, CoCoMo, are of two types. One is basic CoCoMo and another is intermediate CoCoMo. And we saw the formula for basic CoCoMo was effort is equal to A star, that is A multiplied by size raised to B, where A and B are constants and they are scaling factors, I would say, whereas size is the variable, and size is nothing but kilo delivered source instruction. And we said that when size is 6500 lines of code, we typically take 6.5. okay, so A multiplied by 6.5 raised to B. So this is basically for basic CoCoMo. Okay, now let us see what values of A and B are taken for basic CoCoMo, and these values changes based on the types of projects. So projects are categorized into three types. One is organic type of project, second is semi-detached type of project, and third is embedded type of project. Okay, so for organic type of project, A is 2.04, B is 1.05. A for semi-detached is taken as 3.0, B is 1.12, and embedded is given where A is 3.6 and B is 1.20. Now let us quickly see what are these types of projects. So what we really mean by organic type of project, or semi-detached type of project, or embedded type of project. Okay, so say for example, any project which gets categorized as organic is that project basically which organization is used to carry, used to develop. Okay, it's a routine for an organization. The domain is well understood. So for a company, if they get a new project and similar kind of projects have been executed by company number of times, they are pretty matured and they understand the domain very well, then that project would be categorized as organic project. And if for that organic project the basic CoCoMo will have A value as 2.04 and B value that as 1.05. Okay, now what is semi-detached project? Semi-detached project is that project which is complex, but companies still have experience. So it's not routine, it's not easy, it's complex, but company has got experience of executing it. And embedded project is that project where company doesn't have any experience. They have never executed that kind of project before. And a classic example is probably you asking Boeing to develop a software for nuclear reactor control systems. Okay, extremely difficult, because for them that domain is entirely different. Okay, and see, now based on the category of project, as the project becomes more complex, more difficult, the values of A and B are going to scale up. So for organic it was 2.04, now it got scaled to 3.0, and for embedded it got scaled up to 3.6. okay, and that is how your effort is going to change, okay, based on the size. So size, if it's 5K, okay, what you do is, say for example, organic project, a project categorized as organic with lines of code as 10,000 lines of code. So what you will do is, you will do it 2.04, which is A, 2.04 multiplied by 10 raised to 1.05. So this will give you the efforts that was required to execute that project. So this is basically for basic CoCoMo. For intermediate CoCoMo, what changes is, basically if you see, your B for intermediate CoCoMo remains same, whereas there is a marginal change for organic and embedded in terms of A. But actually what changes in intermediate CoCoMo is the basic formula. Okay, you add a EAF here, okay, and it is basically a effort adjustment factor. You multiply the effort adjustment factor with A, okay, and then size raised to B. This effort adjustment factor was not there for our basic CoCoMo. Effort adjustment factor gets introduced for intermediate CoCoMo model. So we saw that basic CoCoMo, the formula was pretty simple, in which we had A multiplied by, that is formula for efforts, we had A multiplied by size raised to B. But for intermediate CoCoMo, we saw that there is a factor which is effort adjustment factor, which we got introduced. Okay, and to calculate the effort, this effort adjustment factor EAF is multiplied by A, which is further multiplied by size raised to B. So there is a difference between basic CoCoMo factor formula and intermediate CoCoMo formula. In intermediate we have EAF which got introduced. Now what this EAF is, so there is a project characteristic table, okay, and with the help of this project characteristic table we actually arrive at the value of EAF. Okay, now if you see very clearly, this project characteristic table comprises of 4 attributes. So there are 4 blocks. Okay, so something which is in bold, first line, which says product attributes. Then there is something called as computer attributes, personal attributes, and last is project attributes. Now these attributes have got values in terms of very low, low, nominal, high, very high, and extremely high. Okay, now based on what is the type of project, what are the type of resources in terms of programmers, coders, designers that are available, what are the different constraints in terms of computing space, and what are the different products attribute in terms of software, in terms of database that are required. Okay, one has to pick up the appropriate whether it's a very low, low, nominal, high, very high, or extremely high. Now this basically table is a fixed table. Okay, now so one has to refer this table while calculating the efforts for intermediate CoCoMo. So let us see typically with an example. So now what I intend to do is, we will go through one of the example, a numerical example, okay, which will then basically help you understand how to calculate the efforts. Okay, so here is one example which I have taken, and the problem says, and we are going to calculate efforts for intermediate CoCoMo. Consider a database system needed for an office automation project. The requirements document shows 4 modules needed. Okay, so basically sizes are estimated as follows. So data entry comprises of 0.6 KDSI and 0.6 KDSI. KDSI stands for kilo developed instructions, kilo delivered instructions. Okay, so basically 0.6 is nothing but 600 lines of code. So that's for data entry. So total, if you see, including data update, query and report generation, system size comes out to be 3.0 KDSI. Now the project is judged as organic. So we basically saw what organic project is. Project categories, there are other 2 project categories like semi-detached and embedded. Organic is typically that project type where organization is used to carrying out such projects. They have very good domain understanding and they are experts, and it's a routine for organization. So project category tells us what should be our values of A and B, and we have seen those previously. What will be the values of A if a project is of type organic, and for especially intermediate CoCoMo. Okay, so just to kind of give you a feel, the below table actually gives us the intermediate CoCoMo A-B values. So for organic, A is 3.2 and B is 1.05. Okay, so that's where the project is judged to be organic. So A is 3.2 and B is equal to 1.05. Now manager rates project details as follows. Now when you are going to solve numericals in examination, typically these characteristics would be given to you. Okay, so these characteristics are given. Complexity is high, 1.15. so storage is high, 1.06. they are nothing but effort adjusted factors. Experience of programmer is low, so it's 1.13. okay, so if you have to search this in the table, you will immediately find out. Okay, so product attributes requirement software reliability, if you see high, that line gives in the high 1.15. okay, so the very first line, okay, in which numericals are given, in that line if you see 4th column, so for required software reliability it is 1.15. okay, whereas in personal attributes, if you really see the analyst capability and applications, basically applications experience is low, and hence if you see in personal attributes, second line, second column, which is 1.13. okay, so that is how the experienced programmer, which is low, and 1.13 is clearly there. okay, then so this is how you get your EAF. Now typically what happens is, rest of all which are not given there in the table, okay, then if it's not given, then typically the value is considered as 1.0, which is nothing but nominal. Now if you see the person months of the project, how EAF is calculated. So 1.15 multiplied by 1.06 multiplied by 1.13 multiplied by 1.17. So what I am basically doing is, to calculate EAF, I have multiplied all the EAFs that are given, that is 1.15 multiplied by 1.06 multiplied by 1.13 multiplied by 1.17. okay, so this, and rest is all nominal 1, so anything multiplies by 1 is 1, and it's pretty simple. That's what we are aware of. Okay, so that EAF multiplied by A, value of A is 3.2 and value of B is 1.05, and 3.0 is nothing but my system size, which is KDSI, lines of code. Okay, and person months, PM is person months, which is my effort, and that is how I calculate this. Okay, and finally I get person months to be 16.33, which means it is greater than 16 person months is what is estimated. So efforts required is nothing but 16 people required to work for 1 month. So this is how intermediate CoCoMo is calculated. I hope you understood the significance of EAF. I hope you understood what is a basic CoCoMo, what is an intermediate CoCoMo, what are factors, scaling factors A and B, and also KDSI, which is size. Now let me reiterate again that CoCoMo is not followed in industry currently because of the fact that this model was based on the measures of projects taken during 70s. So whatever technology that was used in 70s is no more in existence. Okay, so this probably was used till 80s or mid 80s. Okay, so CoCoMo is no more used, but for us to understand how estimates were done in those days and what were the different factors that were seen. Okay, so it's important for you to understand this model. Okay, how we calculate the person months. So if you like this video, do like and share it. If you have any questions, do send me in your comments. Okay, and in next video we are going to talk about function point model, function point analysis, which is widely used in industry. Till then, bye. Thank you.